Okay. So making shapes in P5. We previously played with triangle and quad, right? And the way that those functions worked is we had x1 and y1, x2 and y2, x3 and y3. So we had three coordinate pairs, right? We had our x in the horizontal axis and our y in the vertical axis. And same with our quad, but we had four pairs of coordinates. And now we're going to play with another tool that's called begin shape. And so begin shape allows us to increase the number of vertices, right? And just for a quick vocab recap, right? If we have a shape, such as this triangle, each one of these is a vertex. And the plural of vertex is vertices. And so using the begin shape tool in P5, we can increase this number of vertices beyond 3 in the triangle, beyond 4 in the quad, and extend it to as many vertices as we would like. So let's just really quick, I'm going to go over that. So we'll start out easy. We're going to do something that's basically the same as doing a triangle first. We're going to remember that our origin point is up here in the top left corner. And if we wanted to draw a triangle that had points in these orientations or in these coordinates, let's just say this is at 100 pixels over and 100 pixels down. And this one is 200 pixels over and 100 pixels down. And this one is, let's just say, 190 pixels over, 190 pixels down and 150 pixels over. Okay. So if we're using the triangle function, we would say triangle and then list all of those coordinate pairs. With create shape, we do something a little differently. Begin shape. I keep saying create shape. I don't even know why. So we have begin shape with and that's an entire line of code. Little b, capital S, parentheses, and a semicolon. And then this is a function that has like a partner function that is akin to the closing parenthesis. So that is end shape. And we're going to do this in the editor momentarily. And between those, we're going to use another function called vertex. And inside that vertex, we put an x and a y coordinate. And we repeat this as many times as we need. To create our shape. So if we want a 3-sided shape, we're going to define 3 vertices. And the thing is, I can put as many vertices as I want in there. And so let's switch over to the editor, and then we can play with that. All right. Okay. So, and I'll just switch my camera around as well. All right, so Get my lights on, remote control. So now, what we're going to do is, I'll just start with the very basic starting code that happens when you start a new sketch. And first thing, I'm going to rename it. So we'll say begin shape example. And I'll press Command S to save. Always save your projects. I assume that many of you have had it happen before where you work on a project and forget to save, something happens and it's lost. It's a real bummer.
Too much.
Too much, yeah. So the answer to that is just like, have your finger on that Command S, just have that as like a nervous twitch. Always be saving. And then you won't be as bummed out when it crashes. Anyway, so moving on, I'm not going to bother changing any of this now, but just after this background, remember, because our code is run sequentially, anything we want to appear on the screen, we have to put after that background at a later line of code, at a higher number of code here. I'm sorry, these are the numbers that show the line number of the code that we've written. So here I'm going to say begin shape. And I'll just then add that end parenthesis, end shape. So now I know that whatever I want to do is going to be, with vertices, is going to be in here. And I'm just going to put an indent there so I can see that that is a like a nested action that I'm going to do next. So vertex, what did I say? 100, 100, vertex 200, 100, and vertex 190, oh sorry, 150, 190. So let's just see how that looks. Not too bad, but if we look closely here, there is a little bit of a problem. See how this side is doesn't have a stroke on it, how we have this black outline between those vertices that we've defined, but we haven't gotten all the way there. We've defined this, this, and this. So let me just zoom back out. So there's a couple ways that we can solve this, but first, let's just go over to the reference section, P5 reference. And if I do a Command F to find in page, begin shape, there it is. I can click that. And now, oh, what's this? This might be something interesting to us. There's a optional parameter in that end shape function. So let's scroll down. Scroll down. Oh, well, that's actually kind of annoying. They don't actually define it in this one. I guess we have to go to the end shape. So I guess close is the only option for that one. There's other options for begin shape, but we're not going to worry about that. We'll just go over here and we can say end shape, close. And now if we rerun this code, we can see that it has indeed closed. Another way that we can accomplish the same thing is by just adding the first vertex to our list again. So accomplishes the same thing. So this is fun because now I can add as many as I want. So let's just try 50, 100. I can do that, 50, 130. And let's add something over here. So that looks like it would be about 75, 10 maybe. And then I'll just close it up. So I can draw any shape I can think of that has these straight lines. So this can be useful if you want to, say, make a, you can make a crown that sits on top of your head or something. But there's another tool that we can use that can make it a little bit more smooth. And that would be, instead of using vertex, we can use a different function called curve vertex. And that looks like this, where it has a little c and a big V for curve vertex. So let's try just replacing all of these vertices with curve vertex. And so this is going to be a little bit odd when we do this. It's probably not going to look the way that we expect it to. So let's just run it and take a look. So it looks pretty interesting, but then there's this straight bit here. And the reason for this, I'm going to switch back to my other camera to talk about that real quick. The way that curve vertex works. Actually, before I do that, I want to go back to a simpler shape. So I'm going to just go back to when we had just that triangle. Okay, so back to just that triangle. So this is even stranger than we might have expected. But now I'm going to switch back to my other camera so we can look at that. Okay, so curve vertex. Let's look at curve vertex. So when we're working with curve vertex, we need to think about what determines a curve. How can we describe how a curve should be, right? If I'm telling the computer just that curvature, right? I mean, just these points are being defined. And ideally, I imagine if I think about this, what I want this to make, so first we'll draw just the straight line triangle of it. What I might imagine should happen would be something like that. And this is actually a quick tangent. This is an interesting type of shape. I think it's called a roulet curve. But specifically, if you take a compass and you draw a line of equal size, of equal length from here to here, and then you trace on your compass to this other point, what that means is that every point on this line is an equal distance from this this corner of the triangle. And the same goes for every other triangle, every other corner of the triangle with its opposing face. So this shape can roll, and actually, even though it moves crazy, the height of it doesn't change. I'll share a link to that afterwards for you to look at. Let me just make a note to do that. Anyway, so this might be something that I expect, right? But what we got was just this part of it, right? We just got this little section right here, which, like, we got a little bit of it, so that's good, I suppose. But the reason that we don't have the rest is this curve, the curve here, is influenced both by what happens before and after it, right? So let's go back to Illustrator, right? Where if we're using the pen tool in Illustrator, right? If we click somewhere and then we click somewhere else, we get a line and that handle that we can pull, right? And that handle, like if we have a curve that looks like this, we have that handle here, and maybe a handle there. And what that handle is doing is it's deforming a straight line, right? So with the original just straight lines between these points, these handles tell that line how to curve. And it pulls the line in this direction on this side of the point and this direction on this side of the point. So we can see if I were to pull this line like a rubber band, kind of, we could get it into this curve. But that curve depends both on this point, and how much it's being pulled, right? And now between these 2 points, the curve here, we have this compound curve, and that compound curve depends on this point, this handle, and this handle, right? You see how if we look at our straight line, it's being pulled this way, and it's also being pulled this way. So because P5 isn't a, doesn't use like graphical tools like Illustrator, we have to tell it how to deform that straight line on both sides of the point. So the way curve vertex does this, or the way that the begin shape and end shape functions use curve vertex, is that it's going to use the first and last several vertices just as information of how to begin that curve. So what we need to do is we need to duplicate some of our other points. So let's just go back to the screen and we can go through that together. Okay. All right, so now that we are back in the screen, right, let's draw our triangle behind this, just so we can see our points. So I'm gonna copy and paste all of that just right above. I'm gonna just change all those back to vertex. All right, so with those back to being vertex, I'm also going to actually, in my setup, I'm going to make it so this white fill isn't there, so we can just see through. So I'm gonna say no fill. And no fill is going to make it so there's a transparent fill on anything that we might be drawing. So with that, now I'll run this again. And so we can see our base triangle shape, and we can see one of our curves, one of our sides has been curved. Okay. So now what we need to do is we need to figure out how to make those other sides curved. So like I said, we're going to duplicate some vertices. So really quick, so this first vertex right here, its curve is informed by its position, the position of this point, and the position of this point. So we're going to add this coordinate in before our previously first vertex. Vertex 150, 190. So now I start here, doom, 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 doom. And so I have an overlap of these 2 points. So let's just run that code and see what we got. Okay, not quite there yet. Oh, whoops, I added that into the straight vertex. That was my mistake. Okay, so let's try that again. Okay, so we're getting somewhere. We have this one because now this curve knows that it should be being pulled in a direction to get back to here. So if we can imagine, that's why we have this bit of curvature happening here. And so now we just need to add another point here, another point to make this curve happen. So what we need to do is now we need to add this point in at the end. And so that point was right here. So I can copy that and paste that. And so there we go. Now we have our curved triangle shape. And so I'm going to comment out the straight triangle. And now we have this wiggly, curvy triangle. So I'm just going to go back to the board really quick, just so we can, I'm going to draw kind of what we were doing one more time. Okay, so let me just erase what I have here. So so we have the 3 points of our triangle. And so we have to start here. So 1, 2, 3, 4, 5, 6. All right, so to get all of those curves to know where they're going, we have to overlap our triangle, right? So our triangle kind of, if we were thinking about it, it looks like that. So that will allow us, oh, sorry, I'm getting a little glare. So it knows that at this point on the top left, this curve here is influenced by needing to make its way over to that point. And same with all of these. This curve here knows it has to be influenced to get over to that point and over to there. Building on the ideas from curve of using vertex to draw points to create a shape, we're going to get into a little bit more complex code. We're going to talk about iteration. So iteration is a term that you might have heard used in design, where you are iterating on a design, you are repeating and revising and developing a design to make it better. But what it means, I mean, it means to do something over and over. So in P5, the way we iterate, the way we do a repetitive task over and over, is with something called a loop. There's several different kinds of loops, and what we're going to do is called a for loop. So a for loop. And definitely write this down in your notes and maybe pull up the reference page for the for. So the way a for loop works, so we say for, and there's some stuff that happens in parentheses, and then there's some stuff that happens in curly brackets. What happens in the curly brackets is what is going to be run, the code that's going to run over and over and over again. So we'll get to that in a second. But we're going to look at what happens inside of here. So first, what we need to do is we need to declare a variable, specifically a very local variable. So let I equal 0, we'll say. And so when I say a local variable, we're talking about variable scope. And variable scope means where in the code this variable is available to us. Because we have to define the variables with a name, right? There's the variable name and then the value that's stored in that variable. We can have variables that are available to the entirety of the code, and we can have variables that are available just to a little bit of the code in case we want to reuse those names. So in this case, this variable that's called I only exists in here. So I only exists within this scope. So the scope of the variable I is only inside of this for loop, between these curly brackets, basically. And so now what we need to do is we need to do something with the variable I. So we're going to say, this will be declare iterator. So iterator, that which iterates. And so what we're going to do is we're going to have I, the value of I, count up. And the way that that works is we are going to add 1 to it multiple times in a row. But first, before we do that, we want to determine how high up we want to count, right? We don't want to just say start counting, because then the computer will just go 1, 2, 3, 4, 5, blah, 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 up and up and up and up until it's a huge number that doesn't help us. We want it to only go so far. So let's say right here, I is less than 10. So this is our condition. So only if the value of I is less than 10 will we run this code in here. And last but not least is where we actually iterate. So here we'll say I plus plus. And so if we say I plus plus, that says add 1 to the value of I. So what's going to happen here? We'll start out where I is 0. Then we'll check the condition. Well, the code will check the condition. It'll say, is 0 less than 10? Yes. In that case, run the code. We haven't written any code yet, but run the code, and then add 1 to the value of I. And so now we'll say, okay, so now I is equal to 1. Is 1 less than 10? Yes. Run the code, add 1, so now the value of I is 2. Is 2 less than 10? Yes. Run the code, add 1, blah, 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 up until we get to 9. So I is equal to 9. Is 9 less than 10? Yes. Add 1, or sorry, run the code and then add 1. And now the value of I is 10. Is 10 less than 10? No. 10 is equal to 10. 10 is not less than 10. So this condition is not satisfied. The code does not run, and then we move on to whatever lines of code happen afterwards. So what we're going to do really quick, we'll move this into the editor first, and we will play with that. And what we're going to do is we're going to use a very simple line of code, and I'd like it if you're following along with me here. We're just going to say console.log in parentheses I. And so what this does, I'll show you in a moment in the actual editor. Console is a tool that's part of the browser that allows our code to export numerical or text information. so that we can look at the values of different variables to make sure our code is running correctly, and also if there's any errors, they're going to show up in the console. So what we're going to say is we're going to say, please print the value of I into our console, and then we'll be able to see what's going on here. So, okay, 1 second, let me switch on back. Yeah, we're fine. Okay. Okay. And let me switch my video too. Okay. All right, so now what we're going to do, we'll just leave this code in there. It doesn't matter if we do that. So I will delete my straight-sided triangle. What we're going to do is in here we'll type for let I equal 1 semicolon I is less than 10 semicolon I plus plus. And then we'll make our sides here. So, and now we're going to put in console.log I. And so right here down at the bottom of the screen, we have a console that's built into the web editor for P5JS at p5js.org. And we can also, if we control click or right click, you can go to inspect console. And so there's one built in, there's one built in to the browser itself. So once we're doing stuff where we're not just using the P5 editor, once we're uploading onto GitHub, the one that's built into the browser is going to be very helpful for you. All right. So I'm going to close this down because we already have a console here at the bottom. So I'm going to just press play. I'll run the code. And I'll just stop it so that it's not scrolling. And if I make my console larger, you can see that we're counting up from 0 to 9, and then repeating. Because remember, our draw function will run over and over and over again. So it's going to repeat this every time the draw function loops. Okay, so now we have something that's counting up between 0 and 9. So now we need to think of a way to use this in an interesting way. So the first thing we're going to do, we're just going to use this to draw a nice regular polygon. So instead of having to do all this like math of determining all these coordinates, I don't have to do that myself and write in all these hard-coded values. We can make the computer do that for us. So really quick, what we're going to do is I'm going to switch back to the board so we can look at that together again. Okay. So, and once again, please stop me if there's questions. All right. So remember we talked about radians, right? Where we have a circle goes around from 0, and this is pi radians. This is pi over 2. We have 3 pi over 2, and then 2 pi is right on top of 0. But if we're working with angles, we need to convert that back into coordinates, right? Because our means of drawing on the screen is we have X and Y coordinates, right? So does anyone remember how we get between angles and coordinates? Anybody remember trig? Does anyone remember SOHCAHTOA? Let's just say we want to determine the X and Y coordinates here at, let's just go to pi over 4. So what we need to do is we need to determine, if we have this angle, we need to determine what our vertical difference in height between the center of our circle is, and what the horizontal difference is, right? So we can remember that this angle here, our angular divergence from that 0, that is our pi over 4 angle. And our longest line here, our radius, that's going to be our hypotenuse, which is going to be the radius of our circle, which we can define. And then we have our x and our y. So our x coordinate is going to be, remember, so we have our adjacent and hypotenuse. Because we don't know x and y, we're trying to build up from this angle and this radius to determine our x and y values. So in this scenario, oh, sorry, let me turn this off, got that glare again. X equals the, well, sorry, actually, let me back that off. The, so we have adjacent and hypotenuse. So adjacent and hypotenuse are related to the cosine. So that means that cosine of pi over 4 equals x over r. So that means that r times the, r times the cosine of pi over 4 equals x. And for y, we have the opposite over the hypotenuse. So that's going to be our sine. So I'll do that over here. So sine of pi over 4 equals y over r, which means that y equals r times sine pi over 4. And so now, with this, we have what we need to make a regular polygon, because all we need to do is we need to change this angle, right? We can change that angle to any angle, and we'll get our x and y coordinates for anywhere along there. So, all right, so let's switch back over to the other screen. And so now what we're going to do is we're going to use that along with our shape functions that we've done. So now just instead of logging this, what we're going to do is we're going to use this value of I. We're not just going to print it somewhere. And so this I is going to be something that is going to be our fractional relationship of our travel around this circle, right? So if we have I is counting up from 0 to 9, what we can do is we can turn that into a ratio. We can say 0 over 9, and then through 9 over 9. So we can go through 0 through 1 in a fraction, right? So let's just do that real quick. So we'll say, instead of console log I, we're going to say console log I divided by 9. And so now, if we bring our console up, you can see that we're counting up between 0 and 1 in equal amounts. So we have equal equal changes. So now we can change this into equal radial changes around that circle. So what we're going to do is we're going to change that to 2 pi times I divided by 9. 2 pi being the entire travel around the circle. And there's a built-in variable for that. So let's run that code. And so now we have going between 0 and 6.28, which is 3.14 times 2, so 2 pi. And so now what we need to do, now we have this counting up angle working just fine. So what we're going to do is we're going to use that to create the coordinates of our vertices. So what we're going to do is I've commented out the curvy triangle, because first we're just going to work with straight lines for now. But I want to, outside of that for loop, is where I'll begin shape and end shape. Because I don't want to begin a shape 9 times in a row, 10 times in a row. That doesn't help us. I just want to begin shape, generate all of those points, and then end shape, and then that's going to repeat every time the draw function runs. So now, instead of just logging it to the console, what we're going to do is we're going to say vertex. And so our x coordinate was our radius, which we haven't determined yet. Let's just make a variable for it up here. So I'll make a global variable at the top of my code. Let r equal, let's give it 100 pixel radius. That seems good. 150, yeah. So our y coordinate is going to be our radius times the cosine of this number. And so you might notice here that I have 2 parentheses in a row, and that's because they're nested, right? We have this cosine function, and we have this vertex function. But I need to have a second coordinate for my vertex. So for my y coordinate, it was r times sine of that number. And so this is enough to draw the shape. The problem is where our center is right now. So this is going to draw something, but it's not going to be what we want. So we'll get to that in just a moment. So let's run that code. Okay, so we got a thing that's all off the screen. So that's not what we want. So what we need to do is we need to translate it down. So what we're going to do in our draw function, we're going to say translate width divided by 2 to the center of the screen, height divided by 2 to the vertical center of the screen. And there we go. Now we have a 10-sided shape. So now we can, yeah, good eye. I wanted this to be the same number here, and I want to count up to 6 because we have to repeat 1 point, right? And so now I could change this. I can say let num sides equal 8, and I can replace all of these 6s with that variable. I can change it to whatever I want. 100, that's going to look pretty much like a circle, but there's actually 100 sides being drawn here.